Okay, so in this video, I'm going to talk about kind of the introduction to triangle congruence proofs. We've spent a couple of days on this in class on Thursday and Friday of this week. And so I wanted to make sure I have video for those of you that have been gone, just kind of explaining the basics of these proofs so that you're able to jump back in, hopefully, when you are able to be back. So when we write a proof in math, what we're talking about is writing a deductive argument where we're being very explicit about every single thing that we know and how we know it. A lot of this stuff is going to seem like it's a bit overkill, but this is how math works. We make sure that we are very explicit and we justify every single thing, even if it might seem like it's obvious to us, because we want to make sure that we are really explaining 100% that something has to be true. And we're not being careless and making assumptions that turns out later on might not actually be true. So when we are writing proofs in this class, for the most part, we're going to be using flowcharts because I think that they really do a good job of, first of all, showing me that you are thinking through the process in a logical way. And also they give us some visual structure to the problem that you're going to be able to, look at every single time we see a proof and kind of follow a similar pattern, because all of these proofs relating to two congruent triangles are going to follow the same kind of pattern that we'll see in just a second here. So this is an example of what a flowchart proof is going to look like for us, kind of the basics of it. One of the things that I want to start off by talking about in this case is just a matter of flowcharts are not something that we only do in math. One thing you will see, or one place you will often see flowcharts, is in an English class or in a history class when you're planning out an argument that you're going to present in a paper. This is a very common pre-writing strategy that you would learn about in an English class and maybe use in something like a history class, anywhere you're writing or explaining yourself. So oftentimes in an English class, if you're writing some sort of a persuasive essay, you are going to organize your thoughts into kind of a general plan of, I'm going to have some sort of an evidence that I'm going to present. Maybe I'll have some other evidence that I'm going to present and some other evidence that I'm going to present. And all of that evidence together is part of what helps explain why two things have to be congruent, why something has to be true. So as an example, if we were going to talk about writing a persuasive essay that says, advertising to children under the age of 10 should not be allowed. That's my argument that I want to make. I'm going to present some different evidence, some claims that I'm going to make, and I'm going to ideally back it up with data. So, one of my claims I might make is that children are very impressionable. That's not how you spell the word impressionable, but just pretend for this case. So I'm going to make the case that children are impressionable. So I'm going to argue that advertising to children is super, super effective. And actually it's too effective because they don't quite understand this idea of just because I see something on TV doesn't mean that I don't always get it. Children are impressionable. I'm going to have to back that up with some research probably. The next thing I might say is, children don't understand the difference between the TV show and the advertisement. So children can't distinguish between TV and ads. And again, I would want to back that up, but I'm building my case. Children are impressionable. Children can't distinguish between TV and ads. And then I'd probably want to come up with some sort of another argument along that same line. Maybe I say something along the idea of children aren't actually the ones making financial decisions. And again, I'm going to back that up with some data. But my argument here is that because of all three of those things, not just because of one of them, but because of all three of them put together, that is why advertising to children should be illegal. And so in an English setting, we're not specifically looking for every single claim you're making backed up. Although if you ever go and take English classes especially in college or beyond college where you're doing actual research, then yes, every single claim you make will be expected to be backed up with some sort of a citation to research that's been done. And I really want to try to bring that point that proofs in math are really just writing persuasive essays in an English class. It's the same kind of deal. So let's take a look at an actual triangle example, because that's the whole point of this, right? So what you're going to get anytime you do a proof is you are going to get usually some picture. You don't have to technically have the picture, but you're going to get usually a picture. You're going to get some given information, and you're going to get a statement that you are trying to prove. So one of the first things I always want to think about here is the fact that whatever I'm trying to prove has to be true. If I go to my very last step in the proof, I know right away that my goal is to prove that triangle ABC is congruent to triangle DEF. The whole point of this proof is to prove why that's true. Another thing I might want to do, especially in these easier examples at the beginning, is look at my pictures, look at the givens that are written down. If they're not marked in the picture, mark them in the picture, and decide, can I prove these are congruent, and which conjecture is it? And so in this case, all the information is marked in the picture. And so I can look at this and I say, well, that's an angle, that's a side, that's an angle. I'm going to use angle, side, angle. That's how I know these two triangles are congruent. And we've really done all of this so far. We've talked about naming congruent triangles and writing down why we know they're congruent. The big step now is these boxes that come before this step. And that is to say that each individual reason that goes into knowing these triangles are congruent, we have to provide a statement claiming that it's true and a reason why it has to be true. And so in this case, I'd probably start out by saying, let's just say why we know each of these angles are congruent. Angle B is congruent to angle E. Why is that true? In this case, it was just marked in the picture. It's our given. That won't always be the case, but some of these easier ones, that's going to be the case. The next thing I might say is, well, I have these sides that are congruent. This side here is congruent to this side here. And I name sides by using two letters. So side CB is this side, connects C to B. So side CB is congruent to side EF. That is also given to me. And then my last thing is I've got these last angles, ones with 2 marks. So I could name them angle C. Remember, I just want to remind you that you could also name these as using 3 letters. So if I highlight this angle here, besides just calling it angle C, the other thing I could call it is angle ACB. And that would be congruent to this angle, which we could call EFD, angle EFD. And that's also given in this one. So in this case, all of the stuff that was used was just the givens and then ASA. Really nothing we haven't been doing in class before we started talking about proofs. What I really want to do, or why I really wanted to do this question first, was this exact same structure is going to show up in every single proof we do. It's not always going to be givens, but what you're going to be looking at is if these two triangles are congruent by ASA, I better be talking about why these angles are congruent, why these sides are congruent, and why these angles are congruent. That's what ASA means. If 2 angles and the side in between them are congruent, then the triangles are congruent. Your job is to tell why are those angles and sides congruent. Okay, let's look at another example that uses a little bit more than just being told what is true. So in this case, we've got 2 givens and nothing marked in the picture. One thing I would really strongly encourage you to do when you see something like this is, as you read these off, do 2 things. So I'm going to read AD is congruent to AC. Well, that's this segment and this segment being congruent. So I'm going to go ahead and write that down in my proof, as well as, like I just did, mark it in the picture. So I know AD is congruent to AC. That was given. I also know, I'm going to change colors just to kind of highlight what's going on here. I also know that angle DAB is congruent to angle CAB. So DAB is this angle and CAB is this angle. So I'm going to go ahead and mark those in the picture and write them down here. This is where you start to kind of think why are we doing all this? Because it told me that. Why do I have to write it down again? And we just want to be very clear about where our reasoning is coming from. We know that's true, it's given. I'm going to write it down and say I know it because it's given. The last thing I know, and we've talked about this when we've discussed just congruent triangles in general, is anytime I have a shared segment between 2 triangles, I get to count that as one of my pairs of sides because every segment is congruent to itself. I know that segment AB has to be congruent to segment AB, and the fact that it's a side in both triangles means that I get to count that as one of my sides, and that is the reflexive property. Now, taken together, we've got a pair of sides there, a pair of angles there and a pair of sides there. Don't necessarily just base it on what order you chose to put them in the proof on. Make sure you look back at the picture and see, okay, what conjecture is this? In this case, I've got my two sides and the angle is the one in between them. So I know this is going to use the SAS conjecture. My claim I'm making is that ABC, triangle ABC, is congruent to triangle ABD. And that is the SAS conjecture as my reason. So in this case, I had to know something besides what was just told. Now, the next thing I want to talk about here, and I know I'm going a long time here, but this is covering, again, like 2+ days of stuff we've done in class, is what are some other things that are very common? Reflexive property, whenever two triangles share a common side like that, is super common. It is probably the most common thing you're going to see. We've also got a few other ones, and I've just kind of went through and found 6. I've posted these around the room, so you have these to look at. But the first one being the reflexive property. Most common thing you're going to see for the reflexive property is anytime the two triangles share a common side, you get to use that as one of your side pairs that are congruent. Then, even though we've normally used it with sides, the reflexive property can also be used with angles as well. And so shared angles are definitely much less common, but imagine I have two triangles that look like this. These two triangles do have a shared angle right at the top there, and the reflexive property says that angle is congruent to itself. So if that was A, I could say angle A is congruent to angle A, and that reason would be the reflexive property. Those are definitely going to show up in some of the harder examples, but you probably will see that. Next up, we've got vertical angles. So vertical angles, you've seen these before in some of the, just where we had to identify why two triangles are congruent. But anytime you've got two lines that cross and the angles opposite of them are in one in each triangle, look at the vertical angles. Look to see if that's one of the pairs of angles that you can use. Vertical angles are very, very common to show up. The nice thing about these first two, reflexive property and vertical angles, you don't need any additional information to know that those two things are now dismissed for lunch. You don't need any additional information to know that those two things are true. Anytime you see a picture that looks like this, think of vertical angles. Anytime you see a picture that looks like two triangles that share a side, think reflexive property. Next up, we've got angle bisectors. Now, these two, you're going to need to be given information. So what you would see on these is if you have a given, I'm just going to give an example of this picture here. There's A, B, C, D. If I was given a statement that said like BD bisects, BD is a segment, bisects angle ABC. Well, that isn't directly telling me that two angles are congruent. Bisect does mean that it splits an angle in half. And so because of that information, I am able to determine that those two angles are congruent. Just they aren't telling me that directly. So when I write this down in a proof, what that's going to look like is my first claim is going to be that BD bisects angle ABC, and that is a given. But that isn't one of my directly known, like 3 things. So that one is going to have to lead to the statement that angle ABD is congruent to angle CBD. And the reason for that would be that that's just what bisect means. So I'll usually put definition of bisect, and the arrow will go like that. That can be one of my 3 things that leads to the triangles being congruent. But in and of itself, BD being a bisector is not one of the 3 things. So I've got that extra step, and you're going to see those showing up in some of those B-level proofs, those kind of like proficient level questions. Similar things are going to happen if you see segment bisector. If you see something like BD bisects segment AC, that means it's going to split AC into 2 equal pieces. So you could say those 2 pieces are congruent to each other. Same thing with midpoints. If you see something like D is the midpoint of AC, then you would know that it splits into 2 equal pieces. Last one I'll probably mention right now is just alternate interior angles. Alternate interior angles come up when you have parallel lines. So anytime you are given something that says AB is parallel to CD, you definitely need to be looking for alternate interior angles. So take a look at something like this. There's my two triangles, and AB is parallel to CD. Well, what I would know based on that is that this angle and this angle have to be congruent. Those are the alternate interior angles. So again, this isn't one of the direct three things that proves the triangles are congruent, but that leads to the statement angle BAD is congruent to angle CDA because the alternate interior angles conjecture. Right. That would be your next step. That would be one of your three. Okay. So I think this video is getting pretty long. I might go ahead and make just another video going through this example, but this one uses that angle bisector. So those first two steps would be the ones that I talked about when I was talking about this. And then your other two things would be, well, I've got another given, so that would go here. And then I could use AB as congruent to itself right here with the reflexive property. And then those would be my three things to prove the triangles are congruent. So look for another video maybe on Monday next week of going over some of these more advanced questions and kind of talking about what you should be able to do to get an A or a B or to be a passing grade. I'll see you next week.